Hello, everyone. Welcome to another episode of the Digital Side podcast. I'm your host, Cliff Madrew, and I'm joined by my co host, James Dowd.
Welcome, everyone. So, today we're going to talk about crowdsourcing medical diagnosis. So, the reason that this is a topic is that I found a show on Netflix. My wife actually found it called Diagnosis, and it's a pretty cool show. Did you get a chance to check it out, Cliff?
I did. Yeah, watched the first couple episodes.
Okay. So, the premise of the show is that there's this lady, she's a doctor at Yale, and she writes a column for the New York Times. And in her column, what she typically does is she goes and she writes about a case that she solved or somebody solved that's kind of interesting and off the beaten path for medicine. So, interesting diagnosis is exotic diseases. So, for this show on Netflix, she had the idea that she could take people who don't have a diagnosis, right, that have stumped medical practice, and she could go out to the crowd via the ability to reach them through the Times and get people's opinions and actually crowdsource the diagnosis. And it's actually kind of a cool idea because it kind of relates back to what we do from a technology standpoint, from a machine learning and an artificial intelligence standpoint. You just saw the first two episodes, but in both of them, these people had essentially stumped their doctors and they were able to come out with, if not a diagnosis, but certainly a viable treatment plan by just going out to thousands of people. And that's what I thought was pretty cool about it. And that's why I brought it up as the topic here for us to discuss.
Yeah, absolutely, and truly appreciated the suggestion as I got to take a look, as I mentioned over the weekend, and it's incredible leveraging the power of the internet, leveraging the ability to crowdsource. And for those of you, if that's a newer term, right, it's just the ability to, get input from, an entire group or collection of individuals on whatever the given topic might be, and at scale, right? So when you think about the premise of this show, the ability to kind of share some of the symptoms with medical professionals, or they actually left it open. So even, those that didn't consider themselves professionals but were hobbyists, or those that really just found joy in trying to figure out people's diagnosis, they left it wide open, and allowed people to contribute. And when you get those varying degrees of backgrounds, both from different medical professionals and different specialists, and people that may approach a problem from a different perspective, it's incredible what you can do. And that really is because of the internet, and the massive amount of collaboration and connection that can occur through the internet. So this is very much a positive story about how you can leverage technology to truly make a difference in somebody's lives, or in people's lives, right? And that was the power of that show in particular, and it was a perfect display of leveraging both the technology to crowd source, but also then to leverage things like, and I could tell based on some of the statistics they were reading, that they were using analytics on the data that they were receiving to understand what the top suggestions were for diagnosis, and what the top areas, and really things that should be considered in terms of symptoms. And it was very interesting and very relatable to many of the conversations I've had with medical professionals and with healthcare professionals around technologies that they're implementing, or around technologies that they're developing. So I thought it'd be a great tie-in to talk about some of that as well. But just again, back to the show, leveraging that crowdsourcing and leveraging the technology, was really effective, and that was the interesting part. And I'll let you talk about that more, because it was really worldwide collaboration that occurs.
Yeah. So, what I thought was pretty cool about it is you didn't just have doctors. I mean, you did have doctors, but it was more than that, right? So, you had like medical students and you had people who were professional investigators and even amateur investigators who just kind of worked the internet to come up with an idea. And then you also had like regular people who, my dad had a similar case, or, my sister seems to have the same symptoms. And then they also had, the one that I thought was kind of cool and I thought was interesting was a veterinarian was on there, right? So anybody who had a medical opinion offered their opinion. And why that's cool from a crowdsourcing standpoint and also from a standpoint of utilizing analytics is that the whole key to any kind of data science is the data itself. So instead of having 10 data points, so if I went to 10 different doctors, I have 10,000 different data points. And most of them are going to be noise and most of them are going to be wrong, right? But the key to the analytics is reducing the noise and finding the commonality and saying, all right, these are the couple of things that we predict could be the answer. And what was cool about the show, the one case in particular, the woman ended up with a mitochondrial issue on her genetics where she wasn't able to process fat properly. So when she would eat fatty foods, she would get all these symptoms. You know, she'd have tremendous joint pain, she'd have breathing problems, neurological symptoms. And all that was related to the fact that she couldn't process fat because she had this genetic problem. But, you know, there was like 10 people who thought, hey, this is the disease. And 10 people were correct. Hundreds and hundreds of other people were wrong, but these 10 people were correct. The cool part is that the process that they went through was able to whittle down all the noise to get to the actual diagnosis. And that's something that from a machine learning and an artificial intelligence perspective, you know, as professionals in that field, it's really fascinating to me is how you take all this data, this really practical real world data, you put it out there to a crowd who gives you thousands upon thousands of answers where 99% of them are incorrect. But how do you parse that data and predict what the correct ones are? And that's the real coolness of the show, but it's also the real opportunity for the technology is how to crowdsource medicine in general, not just for these one or two cases, but for when you go to the doctor and, you know, she says, all right, you may have X. Is she saying that because she has this knowledge in her head? Or is there a mechanism where she can go out to this common thinking, living database that says, all right, these are the 5 possibilities. Here's the one that's most likely based on the experiences we've had in the field. And that's the part that I think is really cool and really powerful.
Absolutely. And the thing that, the thing that relates this directly to some conversations that I've had, and I know you've had some as well, with different organizations. First point I want to make is we aren't there yet, right? In terms of, could you open source healthcare in the sense that, that you make this information generally available to people, right? And there's just a unbelievable amount of privacy concerns, right, and concerns around protecting information, right, and people's personal healthcare information and personally identifiable information. But what's interesting is that there are companies today that are working and developing their platforms in order to leverage similar types of capability, maybe across a smaller source, a smaller data set, a smaller crowd source, if you will, professional doctors, but being able to allow that collaboration amongst professionals and being able to leverage both machine learning, combined with the input from a medical professional to be able to perform better diagnosis, right? And that's where that's where the rubber meets the road in the medical industry, and we're at the cusp of really seeing some of that. So, the example in the particular organization that I was dealing with manufactures equipment for digital pathology. So, scanning pathology slides and software to interact with that digital image to be able to perform better diagnosis and be able to share things like doctor's notes and be able to leverage artificial intelligence to do image-based analytics and understand commonalities between images. And again, similarly here, right, you're coming up with predictions and you're sharing that information amongst, a wide group of professional individuals to be able to perform, and come up with a diagnosis, for their, for the patient. And that's really finding its way into patient care today. And again, that's why it was so relatable, I think, in seeing the show and understanding the challenges that will come and how we're pushing the boundaries of some of those challenges with a show like this. So I thought that was great.
Well, I think you're going to see an acceleration in it. I think you're going to see in the next 5 years, we're going to come as far as we have in the last hundreds with this kind of technology and this kind of ability to sort of leverage intellect against data. I mean, that's the big differentiator right now with humans, right? I mean, we think. it's not just a matter of collecting data, it's a matter of making these intuitive leaps, right? There's no computer today that's not faster than I am. It can read faster, it can identify data faster, it can process data faster. But what it can't do is take a data set, at least not, consistently, take a data set and make these intuitive leaps about it, what it means, how to make a conclusion. We're really starting to do that. And I keep saying that AI is like Schrodinger's cat. It can do everything and it can do nothing until you actually get into doing it.
Hmm.
But, I think in 5 years that, you'll have an automated doctor. I think that, you'll see instead of a nurse practitioner or a nurse, when you go into a doctor's office, you'll see some kind of an artificial intelligence that asks you about your symptoms, takes some basic, baseline data from you, and then says to the doctor, well, here's what's going on. And the doctor analyzes it and says, all right, I got to follow up. I got to make the final determination. But I think some of the more mundane and the examination part is going to fall to AI, and I think this is the beginning of it. And I think the way to get there is through the crowdsourcing and through the increase in the number of data points.
Right. Yeah, the larger the data set, right, the more accurate, in theory, of an algorithm that you can design, right, and that you can execute. So again, I mean, super interesting, very in to your point around collecting that data. I think it's through crowdsourcing in a way, right? Through taking multiple perspectives and different experiences and collecting that as data that can be analyzed. And a big part of that, and a big part of the challenge that I've seen in the industry, is the historical information, because a lot of it doesn't exist digitally. And I think that's another area that's very intriguing to me and to Iron Mountain, as we help customers, because we store and protect a lot of the physical assets as well. And then being able to gain access to that information becomes an even bigger challenge in some cases than data that's born digitally, right? And as you're actively crowdsourcing, you're creating the digital content. As you want to build the most accurate tools, you're going to need historical data in order to better train that machine, right? And so, taking back to the pathology example, taking the physical pathology slides, right, that historical slides that may be stored in an Iron Mountain facility, and digitizing them and bringing them in to be analyzed so that you can train the computer. All of that comes into play. So it's certainly a complex problem that will take time, but certainly over the next 5 years, we're already starting to see, how these things can come together. And again, that's very exciting. So an awesome show that really can get you thinking about the future. And I appreciate the recommendation, James. So
My
thank you
pleasure.
much.
So again, that's Diagnosis on Netflix. Highly recommend you guys watching it. And certainly we're interested in it from a data science perspective. And I hope you all got something out of that as well. So thank you very much. We appreciate you joining us. And we look forward to talking to you again on the next episode of The Digital Side.
We certainly do. Thank you, everyone. Take care.